Hello students, in this example, in this video lecture, we will see the force system which is a parallel force system but acting in space. That means the force system is not in two-dimensional planes. So we'll see how to find the resultant of parallel force systems and how to apply Varignon's theorem in this case. Okay students, in this example you can see that I'm having four forces and all these four forces are parallel forces and they are parallel to y-axis. I have the forces acting at different points, so what I need to do is I need to find out the net resultant of these four forces. So that can be easily done. That is 200 acting downwards, 100 kilonewton acting downwards, 60 and 40 also acting downwards. So by simple mere observation and calculation, I can say that the net resultant acting is 400 kilonewtons and that will be acting downwards. Now I need to find out the exact position of this. So for that, we will have to use the Varignon's theorem. And the Varignon's theorem states that the resultant moment will be same as the moment of all the four forces that are acting about the same point. So now in this case, I'll quickly write the resultant vector. I'm calling the forces as F1, F2, F3 and F4. I'll just make a note over here as F1, F2, F3 and F4. So this is nothing but minus 200J minus 100J minus 40J and minus 60J. This is nothing but minus 400J kilonewton force. So I can say that the resultant is minus 400J kilonewtons and the magnitude of the resultant is 400 kilonewtons acting downwards. So this is the resultant that I have got for the forces given to me. Now what I need to do is I need to find out the moment of each force with respect to a particular point. Now in this case, I'll take point D as the source of taking moment. Now from point D, I can see that force F1 is passing. So the moment of force F1 will be 0. The remaining three forces moment we need to find. I'm writing moment about D for all the forces will be moment about D for F1, moment about D for F2, similarly for F3 and F4. Moment about D for F1 is 0. I'll write that. Now about D for F2. So what I need to do is I need to find out the position vector. Now in this case, the coordinates for D is nothing but 0, 0, 0. Whereas for F2, since it is acting in the XZ plane, Y coordinate will be 0 and that coordinates will be along X it is 2 meters and along Z it is 5 meters. So the coordinates are 2, 0, 5. For E, I'll write the coordinates as Along x it is 5, y is 0, and z it is 2.5. For C, it is along the x-axis, so 5, 0, 0. I have got the coordinates for the different forces. All I need to do is take the position vector. So position vector dF cross F2. Position vector dE cross F3 and position vector dC cross F4. In this way, we need to find out the cross products of the three forces that we have. So this will be 0, I, J, K. F2, we have it as 100J, so I'll write it over here as minus 100. I and K will be 0, and it is dF as a position vector, so it is dF, so it will be F minus D, so it should be 2, 0 and 5. So I'll write over here as 2, 0, 5. Similarly, for F3, F3 is 40J, so minus 40 over here, and it is DE. So DE is this position vector, so it should be 5, 0 and 2.5. 5, 0, 2.5 plus I, J, K. F4 is 60, J, so minus 60 over here. Now, it is DC, so DC, so I'll take it as 5, 0, 0, so 5, 0 and 0. So I'll get it as 0 plus I term will be 0, minus of minus 500 gives me 500, minus J, 0 and 0, K term will be minus 200, plus, for the second vector, I'll write it over here as I term is 0, 40 into 2.5 will give me as answer 100. So that will be minus 100, minus of minus 100 that is, so it will be 100 minus J, so this is 0 and even this is 0. For K it will be minus 200 minus 0. So this is done. The next moment vector for I, 0 minus J is 0 plus K is minus 300. So I can write it as, in the simplified form, moment about D for the forces. I'll take the summation of the like terms together. So I'm having 500 I plus 100 I. J terms are 0, so plus 0 J. Then K term is minus 200 K, again minus 200 K and minus 300 K. So this comes out to be as 600 I, 0 and minus 700 K. So this is the net moment that is acting about D. Now, since we have got the net moment of all the three or four forces, now what we need to do is apply Varignon's theorem. Varignon's theorem states that the moment of the resultant about the same point, that is in this case D, is same as the moment of all the forces about the same point. Now I know the moment of all the forces is coming out as this. All I need to do is find out the moment of the resultant with respect to the same point. Now I know that the resultant of 400 kilonewtons acting downwards will act anywhere on this plane, that is the XZ plane. So if I assume any point on this plane, for example, say this point, so the coordinate of this point will be along X and along Z. So the coordinate will be X, 0 and Z. I can say that the resultant is acting at this point. So the moment of the resultant, I can write it as I, J, K, X, 0, Z. That is nothing but the position vector of this point with D. So that is X, 0 and Z. So that is over here. And the resultant is acting along the y-axis. So my I and K component will be 0 and it is acting downwards. So this will be minus 400. I know this moment, net moment is this value. I'll write it here as it is 600I minus 700K. Now I can simplify this determinant as I 0 plus 400Z minus J. J will be 0 plus K. For K it is minus 400x minus 0. So this is minus 400x equal to 600I minus 700K. So now I can equate the like terms. In this case I have 600I and 400ZI. So I'll write it as 400Z is equal to 600, and over here I'm having minus 400xk and minus 700k. So I'll write it as minus 400x equal to minus 700. So in this case I'm getting the Z value as 1.5 meters and X value I'll have to calculate for that. So that will be 1.75 meters. So the X coordinate of the resultant from point D is 1.75 meters and the Z coordinate of the resultant is 1.5 meters. So this is how we can find the position of the resultant by using Varignon's theorem in space force example. I hope you have understood this example. Thank you.